Okay, so what does the word dimension mean? Who wants to tell me what you put, or what you said rather? The word dimension. Yep.
It's like kind of like how long the sides are of
Okay, maybe. Yeah, it could mean that it's not flat. If we just, it depends on how many dimensions we're talking. If we said two dimensions, if we said two dimensions, then that would mean what? That it's what? Flat. If we said it's three dimensions, then what? It's got length and width and height or depth. Okay? So that's what the word dimension means. Okay? Guys, let's get ready for learning by putting all devices in your backpacks, please. I see several devices out on desks. Let's put in your backpack. Okay, you ready? I know, she's kind of creepy, huh? Guys, we are recording. Okay, it says, goal of the day, you will explore dilations to find out how the scale factor affects the area and the perimeter. You have questions to me. So we already know that dilation means to shrink or to grow.
That's hilarious because the eyes are dilated.
Exactly, that was the goal there. Okay, all right, so on your notes, what we're going to do is we're going to use starburst, okay? And we're going to actually apply some scale factor and see what happens to the perimeter and the area. Got it? So first grab one starburst, each person. Okay? Guys, right now, what is the perimeter of your starburst? Okay. What is the perimeter? 4. Thank you. What is the area? 1. There's only one starburst there, right? Okay. I wasn't trying to be tricky. Okay. Now, if I use a scale factor of 3, first of all, what type of dilation is that? It's an enlargement. So what are you going to actually do with your starburst? Each side, we're going to multiply it by what? 3. So go ahead and build. There should be plenty between, listen to me, between you and a partner, there should be enough to do this. I don't know if there's enough for each person at this stage, okay? So figure out who's going to basically work together. But if I multiply each side by 3, first of all, right now, guys, if I just do that, do I have a similar figure to what I started with right now? No, what's wrong with it? It's not a square. What do I need to do? Yeah, I need to fill it in, y'all. I'm making a similar figure. And you're going to make yours line up better than me. Okay? Okay. First period, you ready? Over here, it says sketch of new figure. That's because you're not going to be able to see the starburst once you move in. So I would just draw a square and cut it like a tic-tac-toe board. Okay? Now, what is the perimeter of your new shape? No. 12. Does everybody see where I got 12? Yes. This is back to like elementary school. I know that because my daughter, who's in 3rd grade, is doing area and perimeter right now, and she's putting her little marks and she's figuring out her insides right now. Now, what about the area? 9. Is everybody good so far? Okay. What I'd like for you to try to do with your partner, just the next one. So start with that. So go ahead and reconfigure your starburst to look like that. Okay? And then use a scale factor of 1 to half. What does that mean? Each side is going to what? Shrink by half. Okay, so pause the video if you're going. Enlarge the wheel. Okay. So if I took my original figure and I divided, dimension by half, well, I could start by just cutting this piece in half, like this way. Did I cut it this way? Yes. Now what? Am I done? No, because I have to cut each dimension in half. So I've got to cut it that way too. How many of you got that? And you got that. How many of you left it at 4? Yeah, a lot. That's the trick, okay? What type of a dilation is it? Hello? Reduction. The new figure should now only look like that. What was the perimeter of the original shape? And what's the area of the original shape? 8. What's the perimeter of the new one? And the area? 2. Is everybody good so far? Okay. So what I'd like for you to now try is just the bottom 2. Now that you know how to do it really well, I hope. Maybe about 6 minutes, maybe about 5. I don't know, 6. Go. Okay, guys. You should have gotten that number 3 was an enlargement. Should have looked something like that. Original perimeter was 8. The new one was 16. Original area 3. The new one is 12. Questions? Okay. The next one, it was 1/3. Did you get that it was a reduction? And look, it was only one little square. Did anybody happen to notice a relationship between this one and something else on the page? Tell me. Yeah, it's just like this one, except for the other way around, right? So if you knew this one was a scale factor of 3, if you went back the other way, it would be 1/3. Okay? And then did you get the original perimeter 12, new 4, 9, and then 1? Is everybody good? Okay, go ahead and turn it over on the back. Just do the first 3. First 3 only, okay? I'm going to give y'all 7 minutes. Okay. Look, when we have a scale factor of 3, we know that that's an enlargement, right? What that means, though, is each dimension needs to be getting multiplied by 3. So if it was a 1/2, well, the 1 now becomes what? 3. And the 2 now becomes what? 6. So you should have had over here a 3/6. Okay? What was the original perimeter? No, the original perimeter was 6, right? What is the new perimeter? 18. What was the original area? 2. And what's the new area? Also 18. Is everybody good? Okay. Now, when it's like this, and we have a scale factor of 1/2, that means we have to cut both dimensions in half. So right here, I've only cut that one, correct? But now I have to cut it the other way. So what's left over? Only 3. What was the original perimeter? 16. And the new perimeter is 8. The original area was 12. And the new area is 3. Okay? On this one, we got a 2/2. So now with the scale factor of 2, we're now going to have a, say again, 4/4. What was the original perimeter? 8. And the original area? 4. And the new perimeter is 16. And the new area is 16. Okay. So now, here's what I asked some of you to do. Give me a thumbs up if you think you did what I asked, which was to look for a pattern already. Just give me a thumbs up if you think you found a pattern. Uh-oh, not very many. So now, let me help you. Go back to the very first page. And by the way, if you already know it, please don't comment for everybody else. Okay? All right. I need you to not talk right now. I need you to listen and think. It's a difficult task for some of you, right? Okay. When the original perimeter was 4 and the scale factor was 3, we got a new perimeter of 12. So think right now. 4, 3, 2. here, okay? Go to the next one. I'm only looking at perimeter, got it? If the original perimeter was 12, the scale factor was half, the new perimeter was 6. Look at the next one. Y'all, I moved you over here to focus on another. When the perimeter was 8, scale factor was 2, new perimeter 16. Scale factor 12, I'm sorry, 1/3, perimeter 12, new perimeter 4. So now what I want, because I think I just saw a bunch of light bulbs go off, on the bottom of the page, let's see what we can figure out. First of all, when the scale factor is less than 1, everybody should know that one, right? That is, the dilation gets smaller. Or reduction, that's a good word. When the scale factor is greater than 1, it gets bigger, it's an enlargement, okay? Now, here's what I was trying to get you to find. Are you writing? It says, what is the relationship between the original perimeter and the perimeter of the new image? What would you just put? It's just times the scale factor. That's exactly right. The perimeter increases by the scale factor. To find the perimeter of dilation, you just multiply. So in shorthand, I would write original times the scale factor equals the new perimeter. Original perimeter times the scale factor equals the new perimeter. Okay? That was pretty easy, right? Okay. I'm going to let you catch up for a second. When you're done writing, I want you to go back to the very first page. And please don't say it, just look. Now look at your areas. Please don't tell us, let people have time to think. Okay? Go back to the original. Okay. When I had an area of 8, I need y'all to be quiet, please. Okay, y'all are not. Houston. When it was an area of 8, scale factor of a half, I got all the way down to 2. When the area was 1, a scale factor of 3 got me to 9. Hold up. 1 and 9. If you think you know, see if it worked on all the other ones. When we had a scale factor of 3 and the area was 2, we got to 18. Are you seeing something? Give me a thumbs up if you think you know. Conchi, tell me. That is exactly right. It's times the scale factor squared. So here, I would write original area times scale factor squared equals the new area. The area increases by the scale factor squared. Find the area of the dilation. You multiply it by the area K squared. Okay? After you finish writing that down, we're going to go back and make sure that that's true. Because remember, I was saying, look for a pattern. Easton? I said, look for a pattern. I said, because you're not going to want to always draw this out, or you're not going to have the manipulative skill. What if I told you, I had a square with each side 40? You're not going to want to draw that, right? So you need a rule that applies all the time. Or what if I gave you a number that was a decimal? You know what I mean? Okay. Is everybody done writing? No. Okay. Okay, let's go back to the first page. All right. And now let's see if this is true. So perimeter 4 times the scale factor. So 4 times 3. Does that equal 12? Yes. Perimeter times area times scale factor squared. So in this case, 1 times 3 squared. Is that equal to 9? Yes. Guys, are y'all writing this in? I want you to write it in. This is like the key to this whole thing. Okay? Look at that next one. Perimeter times the scale factor. Well, what's the perimeter? And the scale factor was half. What's 12 times a scale factor squared, well, that would be 8 times 1/2 squared. Well, what's 1/2 squared? 1/4. What's 8 times 1/4? You're just looking for a fourth of 8, right? Which is 2. Yes, I did not think we needed our calculators. I thought these numbers were relatively easy. Okay? Because I was hoping we could square half and such. Try it on the ones that I asked you to do with your partner. Make sure it works every time. Guys, this should always work. If I'm still writing, I don't understand how you could possibly be done. Does anyone have a question of where we're getting all these numbers? Here's my question that's not in the packet. Why do you think that we're squaring for area versus we didn't have to square it on perimeter? Easton, what do you think?
Because area is the unit square.
That is true. Units squared for area, right? Tell me about the word from the warm-up. What was that word from the warm-up? Dimension. Area is always what? Second dimension, 2 dimensions, right? Right? So this is not what we're learning right now, but what if I was asking you about volume? Then that would be cubed. So do you think you're going to multiply the scale factor cube? Yes. We just haven't gotten there yet. We haven't learned our volume. Okay. Guys, do you have a question? All right. The back page. Guys, the back page is your homework, but look, I have lots of notes up here. Some of y'all are missing them. 1, your test review opened on Friday, and it's due tomorrow by 11:59. 2, you have a Canvas quiz that opened today. It's due a week from today. Okay? I'm looking at the clock. We still have 15 minutes. Okay? So if I were you, first do tonight's homework, then test review. If you have time to work on that, that was the last good thing, by the way. Tomorrow's practice. And then if you finish with that, you can start on your Canvas quiz. The Canvas minor, remember, you only get one time